Okay, so this should be our final video for this module, and then I will get to work making you guys some assessments while these things are uploading. So we want to look at pairs of angles, which is, how angles are related to each other or not. Okay, so here's the first thing. We have this whole set of mess of angles up there. Okay, so 1 and 2, it says are adjacent. So this is just being told to you. Oh my gosh, where's my pen? Okay. 1 and 2 are adjacent. 2 and 5 are not. 2 and 5 are not. So the question is, what do you suppose adjacent means? Well, it kind of means the same thing it does in the world. It means next to. So it means they share a side. One and 2 are also complementary. 5 and 6 are complementary. AXB, which is this one, and 6 are not. So here's 1 and 2, 5 and 6. What you might notice about these two, since this is a right angle, and these two lines make it, then everything else is also a right angle. So these two together are a right angle. These two together are a right angle. This one with anything else is not, because it's already right all by itself. Complementary angles add up to 90 degrees, and that's just two. It has to be just two angles. Supplementary, the word's missing there. Supplementary. So you can see that's a similar word to complementary, so you can probably guess it's a related concept. AXC and 5 are supplementary. So look at that. AXF and DXF, supplementary, that's these two. I probably should have switched colors in there. AXB and 6 are not, that's this part. So these are making a whole line. So they actually add up to 180. And honestly, the way that I remember this, which is just made up, so it may not be great, but complementary starts with C like corner, and supplementary starts with S like straight. So supplementary makes a straight line, complementary makes a corner. And that's how I remember which one's which. Okay, AXC and 5 form a linear pair. So that's AXC and 5. That's these guys. AXF and DXF do also. So these guys again. AXB and 6 do not. So far it sounds exactly like the supplementary definition. But the key is here, it's not just that they add up to 180, they're also kind of adjacent with each other, and when you stick them together, they make a line. So I could say that, oops, my goodness. I could say like this angle and this angle are supplementary because you add them together and they make 180, but they are not a linear pair. A linear pair have to be like these two. They have to add up to a line. So these two are a linear pair, these two are a linear pair, if they make a line. So linear pair makes a line. 1 and 5 are vertical angles. So 1 and 5 are vertical angles. 2 and 6, vertical angles. 3 and 6 are not. So look, these are made by the same two lines. So if I put any two lines together, the opposite angles are vertical angles. So these are opposite angles when lines intersect. So the conjecture would be that vertical lines are equal. If you think about it this way, this angle together with this angle makes 180. But this one, along with that one, also makes 180, because see, they both form a linear pair. So that must mean by deductive reasoning that these guys are the same. Because like if this was 70, no, not 70, let's say 130. If that was 130, then this is 50. But by the same reasoning, this is 50. So these should be equal, or a whole lot of things don't make sense. Okay, XE bisects FXD, which means it splits it into equal pieces. Bisects means the same thing before. XD bisects CXE and does not BXD. So these are not the same. An angle bisector splits an angle into two equal parts. Well, I hope you can hear me because you certainly can't read that. Okay, so we want to identify things as vertical, adjacent, complementary, or supplementary. 1 and 4. So 1 and 4 are next to each other. So that's so annoying. I'm sorry if I don't choose pen every single time. Okay, those are adjacent. 4 and 3, they're opposite each other, so those are vertical angles. 4 and 5 are adjacent. They're also supplementary, S for straight, and they're also a linear pair. So we can say adjacent, supplementary, and in fact, these two things together imply a linear pair. 2 and 3, again, adjacent, but also make a corner, complementary. Okay, so down here, we're given that XA and XC are perpendicular, so these two are perpendicular. XB, so XB bisects AXC, which means these two are the same because it splits these in two. And CXD is 32 degrees. Okay, so if these are perpendicular, then each of these is 90, each of these chunks in these quadrants. If these are the same, then they're each 45, because together they have to make 90. 32 and this guy makes 90, so this guy is 58. Vertical pairs are the same, so this is 45, this is 45, this is 32, and this is 58. So that would have been a lot of information to try to keep in your head based on what you were given, but you can just write down all the pieces and make deductions from what you see. So the measure of AXC is 90 degrees. That was actually given by the fact that these two lines are perpendicular here. The measure of HXA is 58. The measure of AXB is 45. GXF, 45. FXD is 45 plus 58, so 103. And then BXE. So 45 plus 32 plus 58 is 135. And of course, we didn't have to write down all these pieces, but I actually think that it makes it easier if you label them all when you've got to, add stuff. So, okay. The measure of two supplementary angles are in a ratio of 3 to 7. We want to find the measure of the larger one. So we've got 3x and 7x And we don't know what that x is. We just know that when we reduce the fraction, we got 3 to 7. But they're supplementary, so that makes straight. So 3x plus 7x equals a whole line, 180 degrees. So 10x equals 180, that's just adding those. X is 18. And normally in algebra you would have stopped, but that's not the question. The question is, what's the larger angle? The larger angle is 7x. So 7 times 18 is 126, I think. The measure of an angle is 14 more than 3 times its complement. We'll say y is 14 more than 3 times x, and we know that y and x are complementary. So x plus y equals 90, complementary, see like your corner, and now we can substitute x plus 3x plus 14 is 90. So 4x plus 14 is 90. So 4x is 76. So x dividing by 4 is 19. And the question is, what is the angle? The angle was the one that was 14 more than 3 times its complement. So y is the thing that we want to answer. 3 times 19 plus 14. So that equals 57 plus 14, so 71 degrees. The measure of an angle is 30 less than 2 times its supplement. So y is 30 less than 2 times its supplement. X plus y straight s. So that means x plus 2x minus 30 equals 180. So 3x minus 30 is 180. 3x is 210, adding 30 to both sides, x is 70. And the question is to find the angle which was 30 less than 2 times its supplement. So y was 2 times 70 minus 30 is 110. So in the diagram at the right, we're given that ABC is a right angle. It's marked that way anyway, but just in case you didn't know. A right angle other than ABC would be what? Well, you can see this is a line, so this is a linear pair. So if this is right, then so is this. So CBD. An angle which is complementary with EBD is therefore CBE because they make a right angle or a corner. So CBE. Angle ABC and blank are both congruent and supplementary. ABC and CBD are congruent because they're the same measure, and they're supplementary because they're each 90, so they add up to 180. So this is CBD again. An angle supplementary, so adding up to 180, of EBD is this one here, because they make a linear pair. So those two have to add up to 180. So FBD. Angles ABF and what form a linear pair? Well, you have two options. ABF forms a linear pair with FBD, but ABF also forms a linear pair with ABE. Either one of these. This one, you can make that line or you can make that line. So we'll choose FBD, but you didn't have to. EBD and what are vertical angles, where then you're not going to have an option. It's the guy opposite, right? So EBD, ABF. If BE is an angle bisector of CBD, so that this actually splits them in half, then what is congruent to what? So if it bisects, that means the two pieces are the same. That one's supposed to be doubled. So if that's double, these two are the same. CBE equals EBD. Okay? And if BC is perpendicular to AD, and AB equals BD, then BC is a bisector of AD. It actually bisects the line because A to B and B to D. So B is the midpoint, and this is a bisector. Angle FBA, so this one here, and CBA there are called adjacent. They're not really anything else to each other. They're not supplementary, they're not complementary. Okay, I don't have a lot of room on this one. I'll try to write small. We'll see how that goes. Get my pen first. Okay. So we want to solve for the variables. So the first and kind of easiest thing is 48 is 6y, right? Because these are vertical angles. So I'd probably start out with that. 48 is 6y, y is 8. That's dividing by 6, okay? So this is also 48. And then all of this together makes a line. So if this is 56 and this is 48, then those add up to 104. So this all together is 104. So that means 104 plus 3x, well, they make a linear pair, so that's 180. I'm guessing you probably don't like this color very much either right now. Back to that one. So subtracting the 104, 3x equals 76. That doesn't divide particularly well, but 104, yeah, that's right. Okay, so x equals 76 thirds. So y equals 8, x equals 76 thirds, and that's what we were trying to do, is solve for the variables. On this one, we have that these two are a linear pair, these two are a vertical pair. There are multiple variables in both ones, both angles, so it's a little bit more confusing. But 3x plus y equals 54. So y equals 54 minus 3x. That doesn't solve for either variable yet, but it means I can substitute. So I'm going to substitute into the other one 6x plus 4y plus 54 equals 180. That's because they're a linear pair, right? So 6x plus 4 times, now I'm going to put in 54 minus 3x, equals 180 minus 54, so 126. So 6x plus 54 times 4, I'm going to distribute now. So 216 minus 12x is 126. So 6x minus 12x gives minus 6x over there, and 126 minus 216 gives minus 90 over there. So x is 15, dividing by the negative 6. But y is 54 minus 3x. So 54 minus 3 times 15, which is 45, so 9. Okay, now up here, we have that these two make a linear pair, and that's all we've got. So x squared plus 8x plus 27 equals 180. So if we subtract the 180, because now we're in quadratic land, and you know that that means we need to get a 0 on one side. So minus 153 equals 0. Factors of 153. We have, and we need it, it's negative, so we need them to have a difference of 8. We have 3 and 51. We have 17 and 9. Oh, and there we are. So we need a positive 17 and a negative 9 to make 8. So x plus 17, x minus 9 equals 0. This one gives x equals negative 17. This one gives x equals 9. Now if I plug negative 17 back into this, I'm going to get a negative angle, and I definitely don't want that. So it's just x equals 9. That concludes this module. So again, I'll post these videos tonight and attempt to get some assessments available to you for the sections. This one will be hard to write in a way that it can be auto-graded, but I'll see what I can do.